Right, so I've given you a bit of an idea as to how the hardware looks and the application that we're trying to solve here. So what I've tried to do is tried my best to take an image here and basically to highlight the key areas that we're going to look at, okay, and then we're going to break it down, understand the system a bit better, set up the project in Siemens, and then start coding, okay. So I mentioned in the video, try and imagine that there's a little tray here that I can sit the product on, the puck, either the metal or the plastic puck, and then if you can imagine that this cylinder here is mounted as well so that it can knock it off from the tray into the conveyor, into the motor that's bringing it along, and then it'll get triggered by the sensors and the rest of the arms. So I've tried my best to kind of add that little bit in. Remember, there's going to be two proximity sensors on the cylinder so that we know when it's fully extended or fully retracted. We've got a little sensor here as well that tells us if there's a part in this tray holder. And then I didn't mention in the video, but we're going to have a start and stop button as well, just to have a bit of a user interface to the system. Okay, so again, hopefully from the earlier video and this kind of slide, you'll have a good understanding of what we're expecting. So then what I did was I just wanted to highlight the inputs and then highlight the outputs. So remember, start and stop, they're both going to be inputs. We've got this part sensor, it's going to be input. Our two proximity sensors that's mounted onto the cylinder, they'll be inputs. We've the inductive sensor and the optical sensor at the end. Okay, so 1, 2, 3, 4, 5, 6, 7 altogether. Okay, and then I've just highlighted the outputs. So just arm deflector is just going to be one output, so kind of spring return valve, one solenoid that's going to activate that cylinder to bring it down. We've got the motor, I'll turn on or off, and then the cylinder, we're going to have two solenoids to be able to move that forward and back. Okay, so that's the outputs. And then if we link this into a wiring diagram, this is what we're going to have, something like this here. Okay, so I've got my 7 inputs lined up, and down here I've got my outputs, I've got my motor, and then I've got the deflector, just a spring return here cylinder. It's going to be operated by the solenoid, and then I've just got my cylinder here, A extend, A retract, to move the cylinder forward and back with its proximity sensors. Okay, so that's the setup that we're going to do. We're going to use OPC communication, so I've covered that in another video with Siemens, so if you do want to look at that to do the setup, I'm not going to go into it in a huge amount of detail. So hopefully you've got a good understanding of how the system will work, kind of what's going to happen, where the inputs and outputs are, and you've got a good kind of visual idea in your head of how the system will work. Okay, so we're going to jump into Siemens TIA portal and have a look at setting up the project from there. Okay, so I've come on into TIA portal. Basically I've set up a project. I've picked a particular type of PLC, again for OPC communication to Fluid Sim. To try and simulate this in Fluid Sim, I need to use a particular type of PLC, so I've covered that in my OPC communication video. So again, check that out just to see the kind of in finer details of setting that up. So basically, if we're starting a project, what we're going to do is we're going to add in our inputs and our outputs straight away. So, very easily adding in the inputs, and we want to do it according to our wiring diagram here as well. So, we'll have start, then we'll have stop, and we'll fill the rest of them in, making sure that we do %I for our inputs. Okay. Making sure that's that. So I'll fill these out pretty quick. So there's my input table all created, and my 7 inputs added in, and then we'll just do the same for the outputs, making sure that the address type is %Q. So I'll add them in again, making sure it's according to my wiring diagram here. So I've got my motor, I've got my deflector, A extend and A return. So I added them in, and there's a mistake. Just got to make sure they're %Qs. Okay, so we can pop them in and pull them down. Okay, so I've got my inputs and outputs generated. Okay, And that's my project setup. So we've understood the problem, we've basically got a good idea of the hardware and the inputs that we need. We've got a wiring diagram for what we're going to go off and what we're going to simulate it from, and then we've set up the bones of the project, the inputs and outputs at the PLC in TIA portal. So then we would want to write our specification about how we're going to, what's the operating sequence, what's the run specification of the system, and then we would start coding it, start debugging it, and get a nice finished product.